have a few hands. How many of you are active .NET developers? Lots of hands. Nice. So how many of you came here for Advanced EF Core? We have a few hands. Now, this talk is aimed a little bit toward common mistakes, which a lot of them might not seem advanced, but what you might not have learned before is the consequences of those mistakes. But toward the end, I'm going through a little bit some of the best practices and some of the deadly sins that I'm going to show actually might be pretty helpful. And yeah, before we officially start, the motivation of this talk was to... I actually seen a lot of people work through weekends or long nights and stuff like that because, you know, an application that worked perfectly fine yesterday or, you know, a month ago, suddenly it doesn't work well anymore. You know, it works slow, it crashes and stuff like that. And a lot of things that I'm going to show you here, what the reasons for that. Now, some of them you'll be like, that would never happen to me. I thought that as well, and it did. And it actually took some of the teams a weekend off because we didn't know what was wrong. And hopefully, with what I'm going to show you, you're not only going to learn more best practices for EF Core, but also avoid those weekends where you're trying to fix production for a bug that you don't know how or where it comes from, and instead just enjoy the weekend. I think I have just one more minute. I'll try to do not disturb. Here we go. Just in case. A bit also jet-lagged. I traveled like 30 hours and arrived just yesterday. Yeah. I just don't know who to watch for the go time. Can somebody raise the hand that will give me the go time? You? Okay, I just watch you. That's good. Yeah, there was one time where I was doing presentation and they said the person that's going to do thumbs up will tell you when the presentation is going to start, if it's going to go live. They forgot to tell me who that was. So I was looking for someone for thumbs up like that thinks alive. So, hi everyone and welcome to NDC London. And I am going to show you some common mistakes in EF Core. And one of those mistakes, some of those mistakes that I'm going to show you today actually happened to some of the client projects, and the consequences of those mistakes sometimes is that a team had to stay at work and do overtime to fix those issues. And you might also have heard, for instance, government rolling out a new service, which then topples over in an hour. Some of the things that I'm going to show you could have been the things that actually happened when they roll out the system. So hopefully, what you're going to learn is that sometimes small things can have big impacts. And with that, I am Jernej Kavka, and I know it's easy to pronounce, so you can just call me JK. And you can follow me on all of these socials, GitHub, Twitter, X, blogs. I come from Australia, so over there I'm doing a Brisbane full stack user group, and I'm also one of the hosts of Global AI, the podcast. I'm mainly a .NET and EF Core developer. I forgot to mention I am from SSW, Solution Architect. And as a side gig, I do Microsoft I do AI a lot, and I'm also a Microsoft AI MVP. All right, so start off, I'm going to show you a little bit of what is my setup, because the point of all of the things that I'm going to show you is that you can try it yourself. And if EF Core 9 comes out, or EF Core 10, 12, 14, you can go back to this code maze and check if that is still true. I'm giving you that power, and I'm also going to show you the things that I used so you can replicate that. Then I'm going to move to 7 Deadly Sins, which basically is, I tried to find 7 things that I've seen in production that was quite terrible and how to fix it. But I'm not just going to show you what can cause issues. I'm also going to show you consequences of that, because I think people remember better the things how you should do when you understand what goes wrong if you don't do that. And that's why I decided to show you both what happens when you do the good thing as well as the bad thing. And some mini best practices that I couldn't slot in any of the slides, just to give you some good best practices for you to take away. All right, so first off, why I chose EF Core, why I love to work with it. One of the great reasons for that is because we have right now lots of different database engines, and all of these engines over here are supported by EF Core. And one of the issues that we sometimes encounter is, especially at the beginning of the project, what database engine we have to pick. Now, if you do raw SQL, if you change database engine, you need to now rewrite your SQL queries. With EF Core, you can actually just regenerate migrations and maybe adjust a little bit your how you create your database DB context. And also, there's a lot of various different ORMs, not just for different languages, also for C#. Obviously, EF Core, we have Dapper, technically more of a mapper library, but you can use it to generate SQL queries with it. Martin is a pretty popular one if you like Postgres, and also Cosmos DB, which right now EF Core is pretty good with Cosmos DB, but as much testing as we have done, we still kind of prefer to have Cosmos DB SDK for Cosmos DB specifically, just because we can have a bit better control for the main reasons why we pick Cosmos DB. And that's the major thing that I love about EF Core. It gives me that flexibility between features, flexibility, and performance. It's kind of the triangle where I can choose in which part of the triangle I want to be. And it's really awesome for relational databases, which most of my clients want to have. So it's 90% of the time the ORM to choose. And another thing that is really awesome is the built-in migration and database scaffolding, among other tools. Built-in migrations allows you to do purely code first without needing to ever generate and run SQL scripts, whereas DB scaffolding allows me to actually take an existing database and generate a DB context in EF Core that allows me then to use that database. So I don't have to not use EF Core if the client tells me not to go code first with that database. All right, so one of the other motivators for this talk was also, excuse me, when I talk with a lot of different developers, especially people who have a lot of SQL Server experience, and done a lot of raw SQL, they always tell me, well, you know, it would have been better if you've written this in raw SQL. And, you know, instead of looking at the problem, why something is slow in EF Core, they just say, well, let's write this in raw SQL, which doesn't solve any problems. It just avoids the problem and try a different solution. And another thing that I also notice is, if you don't understand your tool, you end up with a lot more complex code than it is necessary. And I hope what I'm going to show you is that most of the code that you'll see is actually fairly easy to read and understand what it does, while also maintaining a very good performance. And we rarely benchmark our code. We just say, hey, this is slow. Or we say, hey, this feels fast, or this thing is faster than that thing. And there's no data behind it. And this is why I wanted to show you also the numbers behind all of the changes that we're going to do. And you know, developers, especially senior developers, they love to share the horrors they have seen. Obviously, all of the names are redacted. Now, before we start, just again, quickly, how many of you are .NET developers, just to get a feel? Okay, pretty much the entire room. How many of you have used EF Core? Okay, pretty much the entire room. And how many of you are actively using EF Core? Okay, about half a room. And how many of you have gotten the comment, just write in SQL? Okay. About a fifth. Okay, that's good. Well, what I'm going to show you today is we can actually squeeze out a lot from EF Core. And I'm going to use benchmark.net for the first sin, where I'm going to show you how much memory you can use up if you don't do the right things. And then everything else is going to be using Bombardier, which is going to allow us to do like a very simple load testing scenario. Basically, we're just going to load up one URL and we're just going to smash it. And just in case you're interested in, you know, you run the test and see the numbers being very different. Most of the numbers here are going to be still from .NET 7 and EF Core 7. I tried to get it from EF Core 8. There's some complications, and then the old numbers don't match up quite because I don't have the same machine anymore. And this is my Ryzen 9 5900X with lots of threads and decent amount of RAM. This is important because even though my laptop has more RAM and actually runs some of the tests better than this machine, lots of them it's unable to match. And the test results are not actually that useful, mostly because it isn't powerful enough. And the test data, I'm using a database with 7 million cells. The reason why is simple. Most of the time, we have an application that starts off with very little data. And then over time, that data set grows. And this is where the problem ends up being, is once there's a tipping point, your application suddenly becomes slow. And this is why I choose 7 millions, because that kind of simulates a database that have lived for 10 years and now everything is slow. And they complain about how it used to be fast and all that good stuff. And I'm going to show you a few tricks how to make this work very fast with 7 million rows. Also show you how bad it works if you don't filter out those things. Also, if you use this database, or if you use any other older databases with EF Core 8, you will need to set your compatibility level to 150 or SQL Server 2019. You can put it to, well, 130 plus, SQL Server 2016 or more, because EF Core 8 has dropped the support for all the databases. So technically, you can still run them, but some of the queries will fail because they are no longer supported on those SQL servers. All right, finally, the fun stuff, the 7 deadly sins. We're going to start off with I-queryable to I-enumerable. How many of you suspect what's going to happen here? We have just a couple of hands, which makes me happy and sad at the same time. Not your fault, just you might be surprised about some of the data. As-no tracking. How many of you have heard as-no tracking? Okay, that's about a third. That's good. How many of you know that you don't need to use .include to join multiple tables in EF Core? Just a few hands, that's awesome. Getting all columns, that's a little bit obvious. I kind of squished them together with the number 3. How many of you have used pagination with EF Core? Ah, awesome, you might learn some good stuff. How many of you are using cancellation tokens with EF Core? Okay, we had very few hands and then a few dropped down when I mentioned EF Core. And how many of you are using the latest and greatest of EF Core when it comes to updates and deletes? Okay, we had one hand over there, so that number, 7, might be the lucky one. All right, one thing you should never ask yourself, how bad can it be? Do not ever ask that. You don't want the answer. All right, let's start easy. I-queryable to I-enumerable. How bad can it be? Well, let's try to see what the problem actually is. So here we have sales table. We convert it into a list, and then we count it. Some of you might probably look at it and it's like, oh yeah, the problem is pretty obvious. And then we have this one. See, here we're having the sales table. And we put it in I-enumerable variable, and then we count it. You might suspect some problems here, but, you know, it does look kind of reasonable. And then we have a method that does basically the same thing. Just when you call it, you don't actually see that. Well, the problem is they're all the same. So if you thought this was bad, the first one, well, everything else is actually the very same thing. I'm seeing some people taking pictures, so I'll wait for a few seconds. So what's going on here? Well, first off, we have the HTTP request over here, and then we have this I-enumerable. This sales table gets casted into I-enumerable. And what happens next is it actually gets evaluated up to the point it got casted to I-enumerable. And it get converted into select star from sales. Now remember, this is a 7 million rows record. But you know, things get worse from here. Because SQL Server is like, yeah, sure, I'll give you 7 million rows. And then what does then happen is EF Core digitally passes every single row, every single column, and even adds tracking to it, which I'm going to go back to it later. And then, in memory, when you have everything loaded in RAM, counts them, which basically does nothing else than just check one memory allocation in RAM, because that count already is calculated by that time. And then it disposes the 7 million rows. Now, the structure of net sales is very small, but the impact is big. So here is what you should do. Use I-queryable, and I'm going to show you why. Because over here, we have sales.count, and that gets converted into select count star from sales. And we only get a single integer back. So basically, we have almost nothing that we need to garbage collect. So basically, the only difference here is adding iQueryable. But you know, the question here is, how bad can it get? You know? How bad is using IEnumerable instead of iQueryable in the wrong place? Well, this is a million times more memory usage than using iQueryable, you know, not a big deal. And it's only 64 times slower. Also not too much of a big deal, right? It takes 3.5 seconds to run compared to 60 milliseconds. You know, a little bit difference there. But you know, I like to load test things. With the question, how bad can it be, gets even worse. And here, this is the only test. You might here see the number of connections is 5. In most of the tests, I have 10 or more. With this one, my machine was unresponsive for 15 minutes. For 15 minutes, I wasn't able to move my mouse before I was able to run the next one. So at that stage, I was saying, I'm going to reduce it to 5 because that is only about 8 minutes of my machine not being responsive. That's better. So I'm not showing you the absolute worst case because my machine, I like to use my machine. And you know, this is a 64 gigabyte machine here. I basically reran this on my laptop just, you know, for sake of showing you how this looks like on a machine that can actually allocate that much memory. You can see there's a pretty good chunk of 64 gigabytes. I think it was about 30 gigabytes, which means if you have a 32 gigabyte machine, you probably won't be able to see that. It's just going to end at 99% of RAM, and then it's going to start to trash your hard drive or SSD. So yeah, this is how bad it can go. This could have gone even worse if I wouldn't have that much memory. But if I load test with iQueryable, we're getting respectable 130 milliseconds to count 7 million cells. And this is against exactly the same circumstances. You can see here we have 38 requests per second, opposed to 0.09 requests per second. Just one little type change. So if you take anything out of here is, if you cast in IEnumerable in EF core in the wrong place, your performance can drop by hundreds of times. I have seen tens of thousands of times. It was very good when I fixed it. I could go for early lunch, and then, you know, for 3 hours, I was making a blog post about it and things like that, because I had the full day to solve that problem, and I solved it in 5 minutes. And the client was like the happiest ever because their application just started to run like rocket. Also, you might be able to see, this is where it finishes over here. I think you might be able to see that. I know it's very visible over here. There's a little dip over there. That's the difference. So if there's anything you take away is that. All right, as-node tracking. So not many know about this. So what as-node tracking does is when we add this into the query over there for the sales, it makes it non-tracking. I prefer the phrase, it makes it read-only, because that way it makes more logical sense. It's like, hey, I'm getting data and I'm not going to do anything with it that will impact the database. I think read-only would be better. But if you struggle with what S-not tracking means, just think of it as read-only. And what that means, because some people on YouTube said, hey, don't teach that. They'll use it everywhere and then we'll have problems. The things that you get back are not tracked. That means that if you do save changes, those changes will not be tracked and not be saved in your database. But why is it important for you to know S-not tracking? Well, in traditional workflow, we have EF Core generate the query, we get results from EF Core, we pass and map the data. And what happens over here, we have add tracking properties. And those properties, it costs a bit of memory and CPU to set them up. But this is how you can then call save changes, and it will figure out on its own what you have changed from the data that you got back. Now, the difference if you do without S-not tracking, well, if you do with S-not tracking, this part gets skipped. Now, this doesn't sound too much, but when we look at the data, well, we use up 4 times less memory for the same amount of query. Now, here, the caveat is every single query that you're going to do, you are going to have vastly different results because it depends on how big those data structures are, it depends on how much data you actually get from SQL Server, it depends on a lot of different things. But what I have seen is about at least 25% to 100% on average better memory, less memory usage, and about 50% faster execution. In this particular case, we got 5 times, which is awesome. And you know, it's almost free performance. You just add 1 line, and if you don't need to change anything, that's almost free performance. And yeah, what you should be considering is this has been done with SQL Server Provider. SQLite Provider, at least in EF Core 7, I need to double check that with EF Core 8, did not have any impact on this. So you should verify if performance is the main reason you're doing this, you should verify that you actually gain any performance gains, because in SQLite, as far as I heard from others, you might get a little bit of performance hit because of S-not tracking. But I still prefer to use S-not tracking because for me, this tells to other developers that I do not intend to change that data. It's kind of telling the developers, this is read-only. Do not change this. It is not meant to be changed. And if we load test this, we're getting a little bit better results, and we get a little bit better results mostly because the garbage collector has to work a little bit less. And if anyone looks at .NET performance, usually if you allocate less memory, results on long-term better performance. Might not give you the benefits right away, but might give you benefits down the line. All right, so explicit includes. Usually what we do if we want to add another table to the current table is we use .include and we say which property we want to include. We can also do .join and do more old-fashioned join. That's very similar, just more manual. But the issue with that is, and I have seen that where somebody writes a method which returns an iQueryable, say to sales, and then inside, they just do include .customer, .include something else, then include something else. And then that method is used into something else, which uses none of that. Now, how many of you think that those includes that we don't use won't be used, won't be generated, and we won't get any SQL inner joins and stuff like that. Okay, everyone believes that that's a terrible idea. So yeah, EF Core, when you tell it specifically, include this, it will no longer check whether it makes sense for that to be included. You told it that you need it, and it's up to you that you actually need it. But there is a solution for that. So instead of using .include and salesperson, what you can do instead is, over here I have a select, and what I'm doing is I'm directly accessing the data that I want at the end. That will implicitly include this table and do the join behind the scenes. Now, what is incredible about this is if we change this sales with a salesperson and not include these two properties, or if we add more of them, the SQL will reflect that change. So you now no longer need to manually track whether or not you still need that include. That is done for you. And here, this is a bit a combination also with selecting the columns performance. The performance here is 2.5 times faster in this particular case, but think of it as that the more joins that you do, the more penalty you'll have to pay on the SQL Server end. And the more joins you can get rid of, the faster things will run. And this will allow you to automatically track that. EF Core is doing that for you. All right. We also mentioned about pagination, and we didn't have too many hands in the air for paginations. So what here happens is, and that this is what I believe is why a lot of system crashes after they gone in production or they run in production for a few weeks, is because they don't do pagination. There's a drastically different performance when you run a query that returns 1,000 results or when it starts to return hundreds of thousand results. And a lot of websites, what they do is they just return everything. It's not paginated. And over time, say it goes to 7 million, somehow the users suffer through the software enough to get to that number, which is a miracle on its own. But that causes huge problems. But what we can do here, so here is how that usually happens. So what you can see here is, what often happens is most of the developers don't know how to deal with this part. So what they do is they fetch all of the information, not paginated, and they do .count. And the only reason why they fetch all of the information is because they don't know how to get this .count after they paginate it. So the simplest thing is just get all of the stuff and then deal everything in memory. And that's a terrible thing to do. And I'll show you why that is. And here we have skip and we have take in memory. Now what you should do is you can actually create an iQuery over here. And you have this query over here, and you do whatever you need to do before you need to paginate. So you apply your where clauses, you apply everything that is necessary, right up to the order by. You can also skip or sorting at this point, anything that would not impact the count. And then what you do is you do query.count. Now here I did async because I wanted to be cancelable. And what this happens is this is going to ask SQL Server, hey, if I run this query, how many results I'll get. Now, what is amazing is we can then update the query to include skip and take, and then run it. And we can then get just that one page from SQL Server. And this is a lot faster than the previous example. The only time this is not faster is when the results are less than one page, and the difference is very marginal. It's negligible. So you can see here that we have a pretty stark difference, like 18 times faster on average when we load test this. And this is again 7 million rows. So it takes about 1.3 seconds. Now this is not the same number that you have seen earlier, which was 3.5 seconds. I actually had to reduce the data set. So this is a little bit cheating. This is not the worst case with 7 million. I think it was a bit over 1 million. Because as I said, I want to use my machine. I didn't want to wait 10 minutes every single time when I run this. So you can see here, the performance difference is is a lot better. But the major difference between the one below that use pagination correctly and the one above is that the server is literally not responding when it's trying to process this, because it just is overwhelmed by data and it's unable to get any free time to do anything else. Whereas this one below can still handle other requests. All right. So the next one that we're going to look up is non-cancelable queries. Now this is one very interesting one. How many of you have been DDoSed? We have 2 hands. How many have users accidentally clicking F5 a lot of times to a point where the server was no longer responding? Okay, we have about 10-ish hands. Nice. So what's the problem? What is the problem if we don't use cancelable tokens? Well, usually when HTTP request comes in, EFCO sends the query to SQL Server processes the SQL request, then the user cancels the request, and EFCO and .NET just happily does its thing. And at the end, it just says, was this canceled, by the way? This is like at the very end. If no, it basically returns all of the results, everything is happy. If not, it discards everything it has done. Like everything that it's happened, just gone. Now, if you're updating something, that might be something that you actually want. If it's something where user just smashes F5 because the page is too slow, this will make it even slower. So what happens over here is we add this cancellation token. I just like it to call CT because it's short and nice. And over here, what we do is to link async. And that is going to pass down the cancellation token to EF core. And when the user cancels the web request, or if there's any other cancellation trigger, this is going to cancel not just on the .NET side, not just in EF core side, but also on the SQL Server end. So the SQL Server will also stop doing the query. And that's very important because it's not just the .NET application that can get overwhelmed. You can also overwhelm SQL Server. And then your application is really slow because the SQL Server is really slow. So what happens over here now is everything is the same up to this point when the user cancels. Now this is now being passed to SQL Server, which stops processing the query. And it also stops the .NET end. It kills it. It does the task cancellation exception. And also here, it kills the SQL Server. It finishes the query. So obviously, this is not testing the absolute worst case scenario because I want to use my computer. And what you might be surprised is it's only 2 times faster over here. But what is important to note is not only the down below managed to process more of the requests, it was also more responses faster, a full 40 seconds faster than above. So it's not only about being able to process more requests, it's also about being able to recover from a huge spike or from an attack. And last thing is how we update our entities nowadays. Now, back in the day, this was very inefficient. We used EF core tracking, which they're very great for certain scenarios. And back then, it was the only scenario, unless you want to write raw SQL. But nowadays, first the example over here. Back in the day, what we had to do is we actually, if we wanted to update all of the employees and just for fun, switch the first name with their last name, we had to write all of this thing. It was a lot of work to just do that shenanigans. And when you get SQL out, you'll see that it updates one after another. So that's quite efficient, isn't it? But what happens with EF Core 7 is now we can just use execute update. And we can just say, set the property first name to be last name and set the property last name to be first name. Simple, right? You can write easy code to do some shenanigans like changing first name and last name. Perfect for April 1st. But what is important here is you can change this last name to be a string, for instance, or a variable. You can actually also add a where clause behind execute update. You can do execute delete as well. You can do execute delete, so first dot where, and then we have where employees are not active, and then you can do execute delete, and you delete all of the non-active employees with one simple query. And this is the query that you get at the end. It's just an update, this table, and here we have the set to do the swap. That's it. It's very easy to understand SQL, which makes it a lot easier to debug when things go wrong. And over here, this is like a really small set over here. We have only 23 records. But one of the reasons why I wanted to show you this, even with just 23 records, it is a very noticeable difference. 3 times for just 23 records. Imagine if we do fiscal year processing of sales, and we want to set all of the sales to be processed, all 7 million records. That's going to take several minutes, not just a few seconds. All right, so how many of you have learned something new today? Pretty much all hands. Nice. Now, for the ones that want to have a little bit more advanced knowledge or just looking for some extra best practices, this is the slides for you. So first off, this is more like, senior developers like to share horror stories. The other things that I have seen in practice is this thing. And you would say, oh, this is the same as the first sin, right? Well, you can see they did a dot count, and if the dot count is greater than 0, then return true. And I was like, I understand from where you come from, but please use any. This is really fast. I don't have the numbers, but I hope I don't need to show them that this is really fast. And another thing that I noticed, which I actually very well understand why this is happening is when we have conditional, when we're doing conditional filtering, like for instance, we want to filter by sales ID only if it's not null. There's kind of two different codes that I have seen. One is this one, where they get all of the information they need, all of the rows, before the optional filter, and then they filter in memory. And there's another one where they do .where, and then in brackets they say if sales ID is not null, then compare it with that. I propose a much more cleaner approach. Because we already know that sales ID, if it's null, we don't need to search for it. SQL Server doesn't need to know that we even ever intended to search by it. So what here does is similar as pagination. We are constructing the query as we go. And this is the most optimal way of doing the queries, because if SQL Server never needs to understand that, you actually don't need the sales ID, I don't have to worry about that. Or actually, even worse, for instance, if you use something like SQLite or other SQL engines where they are unable to optimize your query before they run it, they'll actually run all of that stuff. But here, you don't have to worry about it because they will never even know that you wanted to optionally do that. And I think this is a very important concept to know. You can construct queries as you go. Another one is DB context pool. Now, this is very interesting, especially if you want your database to scale. Because what this does is when you request for a DB context, it may recycle an existing one. Now, for SQL Server, the SQL Server provider is already recycling connections for you. But what this one does, it also recycles DB context. And if you use a provider, probably SQLite, maybe MySQL, where the connections might not be recycled behind the scenes, these recycled DB context will keep that connection alive, because establishing and destroying connections takes time. Creating and destroying DB contexts takes time. The only caveat here is the DB context must be stateless. Now, if you do smart architecturing, you can actually make it stateful with uses of interfaces and smart uses of dependency injection. But generally speaking, just think of it as stateless. Now, tag width, this is my favorite thing to talk about, and if you want after the talk, you can ask me all about tag width. What this allows me to do is to add this little thing into the generated SQL. Now, how many of you think this is like mind-blowing? We have a few hands. Okay. Now, let me tell you this. This can save you sometimes a full week. Why? Especially if you have very complicated queries and say that you have dozens of them, maybe about 56 of them. That number is definitely nothing related to real life. And then you have to figure out which one of those is the problem. Now, the problem is 30 of those are identical and they look like it could have been generated by the query that causes the problem. And then you generate the thing, all 30 of them, and then you realize that on the production, it's just a little bit differently generated, the SQL, and it's not quite the same as locally. And now you're going through line by line in SQL to figure out which of those 30 SQLs are the same, only to realize that you're using EF Core 2.2, which can sometimes split queries, which then resulted that none of those 56 queries were actually related to that one. And it was a super massive one. that included one of the 56 queries. And we wasted all our time finding that thing because none of them actually fit, because it was a split query that in EF Core 2.2 was done for you. Which I think engineers back then were saying developers will be very happy about it. Not in that case. Now what this thing did is it added that little comment. And you know what we did? We put every single query, this little comment. And then we found not one, but 3 queries that had the same comment. Now in EF Core 3.1 and EF Core 8, the queries are not being split by default. So you generally get one query for one link statement. Simple. But in EF Core 2.2 times, and earlier than that, that wasn't the case. So for every time the query was split, it actually got the same tag. And now we were able to find that query and finally fix it. And it took us 1 week to find that. But once we implemented this, it took us 5 minutes. Most of the time was just deploying. And this is the power, this little thing. Plus you can now do PowerPoint, Power BI reports and stuff like that. If anyone is interested, this is a big thing in a very small package. And lastly, how many of you like ChatGPT? We have a couple of hands. Now, if you want to create a query, if you want to generate a query with help of ChatGPT, this is roughly what I do and find to have good results, saying you are an EF Core expert and clean code developer. Now, I have a much bigger prompt for that, but this one gave good results still, by also being still compact. You can then write instructions over here. Here you can do it like a small DB context, only what is necessary. Here you can specify all of the entities. And if you want to map this into a type, you can also specify the return type that you want to map to. And this is one of the examples that I did over here. Basically, I just wanted to have pagination with some stats for the salespeople. And it actually done a pretty good job generating this. Like, I could do this in 5–10 minutes, but a novice tried to do that even after watching my talk. They took an hour to write a similar query and wasn't quite right. And this one was right after generating it like 3 times. Don't always take the first one, try to regenerate. And try to see how good the code is. This is one of the reasons why I write here clean code, because it tries to make it better. All right, now before we end, now how many of you have heard the term do not do premature optimization? Now that is generally a good advice, but there's a caveat to that. Because following best practices for the given scenario, that's an emphasis. Not just take a random best practice and follow it for a scenario that wasn't made for. That is not premature optimization. That is just you following the best practices for what we know is a good pattern to follow. When you know that a certain query, a certain endpoint is going to have high load, do not say, hey, it's a premature optimization. Go talk to your product owner and say, this endpoint is going to have performance issue. It should be part of the specification that it needs to be fast. This should be part of your acceptance criteria for completing that endpoint. And for things that already causes performance issues. Now, if it doesn't impact many people, at least make it as a technical debt and document that. But what you don't want is just have this lying around and then your users complaining why the application is constantly slow, why they nothing do about it, when you know you have performance issues and you know that you can solve them. Also, what you should not do is, we'll fix it later with no follow-ups. So what you do is, what I recommend is put a comment in your code and ideally link it to the bug or issue or PBI that says, hey, this needs to be fixed. So when a developer stumbles upon that line of code, they can look into that and say, okay, that's an issue, we should fix it, let's see if we have time now. Premature is optimization as an excuse for bad code. A bad code is a bad code. Do I need to say more? If you really don't have time to deal with bad code, at least comment and make a PBI GitHub issue and saying, hey, this code is terrible, we need to fix it. Don't just say, hey, this is bad code, we'll fix it later. And then 5 months later, it's like, oh yeah, I remember something about it, but I have no idea where it is. Well, I guess we'll find it sometimes. And then it never does. But the users find it by using the application and asking why it's so slow. So with that, here we have some great resources. I hope you find this talk really great. I'll wait for some of the photos over there. I'll put the slides back on later. What I want you to take away the most is IEnumerable. It's great in .NET. It's terrible in EF Core. Avoid it when using with EF Core. As no tracking, awesome. It can give you free performance, but as the name suggests, it becomes read-only. So don't try to change it and then save it and then be puzzled why it's not modified in the database. And sometimes simpler code can result in better performance. So how many of you seen the code and said, okay, that looks simpler than the original code? We have a couple of hands? Yeah, we have a couple of hands. And I think that's the point that I want to also take is more performant code doesn't always necessarily mean, you know, a code that is less maintainable, the code that is harder to read. You can actually be concise, maintainable, and performant at the same time. A nice balance that you can reach with EF Core. And if you're interested in SQL and happen to be in Sydney, although most of the talk eventually end up on YouTube, I'm doing a sequel to this talk where I'm also involving SQL Server. You'll find the presentation over here. I'll share the link there, and thank you.
Hi, any questions?
Got one question over there. Well, wait, I'll make a quick sip of water.
Hi. My question is about the DB contexts.
Yes.
What do you think about having multiple DB contexts in your application instead of one DB context?
It's great, especially if it's connected to different databases. If it's connected to one database, multiple DB contexts, it's also okay. You just have to be a bit careful with the migrations. You can actually change the schema of the first part, the name of the, I forgot the name, unfortunately. You know, when you have DBO dot and the table name, you can change that in EF Core if you're worried about conflicts using different tables. But what I generally do when I have scenario like that, I have one DB context that does the migrations, and then I have smaller DB contexts that just have a view of a particular, just adds those particular tables.
Okay, and another question then. Would you recommend or querying views instead of going straight to the tables? So
that also highly depends. I do occasionally do views. If I do need to do raw SQL, I just do raw SQL. But sometimes what happens, either the views already exist for you, like for the reports. So I use those views. And in some cases, you need to use that multiple times, and DB context can make it look like a regular DB set. So from code perspective, it looks like a table.
Exactly.
Yeah. If that results in better performance, go for it.
Okay. Thank you.
Anyone else?
Yeah, we have one hand over
Also,
there.
if you do leave a little early, just please vote. Remember to vote when you go out.
Okay. I imagine you would recommend. Sorry. I imagine you would recommend always using the tag name for almost all queries then, and
precisely.
And also, are you able to put in variables? So you can put in like a customer ID or something, so you would make it more traceable?
So if we go quickly back to, I believe it was bonus 3, yes. So what you can do here is, I would not recommend the first one, the tag width, to have variables. I would have something that is uniquely identifiable to that query. But that being said, you can actually do multiple tag width. So the next tag width could include the client ID, for instance, which might not be the best idea, because when you execute this, and it includes the client ID, that client ID, if you set up your logs to have sensitive information, will also include that client ID. Now, if you add client ID with tag width, you lose that control of whether you want to enable or disable sensitive information. So before, yes, you can do that, but before you're putting any sensitive information, client ID should be fine, but in some systems it's not. You should consider those factors.
Thank you.
Anyone else?
Yeah, and if anyone is interested, I actually written my own version of tag width. It's tag width context, and I can share you my code where it automatically populates this part. You don't need to put any strings in it, with the class name from where it's being called, or actually file name, because we don't get the class name, unfortunately, from compiler, and the function that it called, the method. So I have written that myself. Plus, if you add if you add a parameter like here, mine basically adds on top of that an additional part. So you can then, if you have multiple queries, you can have. It's almost like commenting what those queries are supposed to do. We have one question over there. Yes. Sorry.
Question specifically regarding the use of include, or maybe actually not using include explicitly. Is lazy loading of navigation properties still something that we have to be concerned about?
The answer is no, because Microsoft, thankfully, made it so that you can enable lazy loading, but it involves quite a bit of effort.
Cool. So by default, it's navigation properties will just be null, basically.
Yeah.
Cool. Perfect. Thank you.
They can enable it, but luckily, the harder Microsoft makes it, the feature to be enabled, the better.
Cool. Thanks very much. Well, I have to end it here, but if you want to go ask a question afterwards, please go for it.
Yeah, I'm happy to do any questions.
Thank you very much. Please remember to vote so we can work out if you like the talks or not. And it helps us plan next year.
Thank you.